the Sunoikisis Digital Classic Spring 2020 program session 4, which is an introduction to programming using Python. This week, our presenters are Paula Granados, who is from the Open University and the Watercolour world, and Matteo Romanello, who's from the École polytechnique fédérale de Lausanne. I'm Gabriel Bedard from the Institute of Classical Studies, and we also have with us today the co-organizer of this series, Dimitar Iliev from the University of Sofia in Bulgaria. To kick off this session, which is primarily going to be taught by Paula and Matteo, I should stress, I want to very quickly give a very brief introduction to a couple of other programming languages which are commonly used in digital humanities, and say a little bit about what's special about each one, and then Paula and Matteo can jump in and say what's special about Python and why Python is what we're recommending for this purpose, as an introduction to programming. So these I think are probably the 5 most common programming languages used in digital humanities. There are also languages like Java and C#, which are used primarily for hardcore programming, I'd say, rather than sort of data programming of the kind that digital humanities use most often, and they might well be used for app development and so forth, but they're slightly less of interest for us. But so XSLT, the Extensible Static Language Transformations, is a language that is very specifically focused for processing XML files and creating other XML files or HTML files out of them. So if I were working with an Epilogue corpus and wanted to produce a website from it, I would choose XSLT as the primary language for that rather than one of the others. JavaScript is a very much client-side web programming language, by which I mean that it's the language that is often embedded in web pages so that certain functions can be performed in your browser to improve the viewing of that page. And this includes things like hiding things on the page, making certain things invisible, making some hover actions happen, and those sorts of things. PHP is also a language most commonly used for web delivery, but it tends to be processed on the server side, so it's often used for turning a database or some other set of data in the background into a set of web pages that your browser doesn't have to handle. The server handles it and delivers that. So a lot of content management systems such as WordPress and similar will have PHP in the background that deliver a lot of that functionality. R is a programming language that, if what you're primarily interested in is statistical processing, mathematics, and data visualization, a lot of people will say this is the most powerful language that you can use for that, and that's very widely used in that area. If you ask a Python enthusiast why you would use Python rather than any language, they'd probably say because it can do all of those things, right? I mean, Python does everything. That's kind of the cliche. But Paula and Matteo might give us a slightly more sensible answer than that to why we're using Python today.
Okay, thank you, Gabby. So before starting looking at Python and doing a short introduction into it, we thought it would be interesting to have a short discussion on why using Python and why Python can be useful for you as digital humanist. And I think there are 2 main questions here. The first one, well, we are gonna open the GitHub repository where the code lies, the source code is stored. So if you open the binder from here, you will be able to see something like this.
Do you want to switch to your screen now, Paula?
Oh, I haven't. Sorry.
No, I can do that.
Now?
Yeah, got you.
Okay. So I was showing the GitHub repository where the code lives, which is the source of the code. And then if you click on Binder, you will be able to open something like this. So Binder allows us to turn the repository into kind of a collection of interactive notebooks. that we can act on only from our browser. So I'm going to open the first one, which is Introduction to Python. And as you see here in the plan of the lecture, we were thinking of having some sort of discussion on why using Python. And so I think there are two main questions here. The first one is why using Python over the other languages that Gabi has given an introduction to. And in my view, I think Python is lately becoming more used in digital humanities because of the functionalities that it offers regarding data science, dealing with data, like the two libraries we are going to show you today. And also because of other functionalities related to natural language processing, natural language toolkits. And I think in that sense, it's one of the most popular languages. And the other question would be, why do I need to learn this? Why do I need to learn Python? And well, for that, there is not a definite answer. It's like you can still be a digital humanist without using Python. You can still apply computers to your research without using Python. But in my perspective and in my experience, Python has given me the way of being more independent towards my own work, being able to design the whole process from the beginning, and also to kind of edit other programs that were already there and make them more specific for my own purposes. So I don't know if, Matteo, you want to add anything, but those are the reasons why I think Python could be useful for digital humanities. Maybe Matteo can add something later. So we're going to start by looking at I don't know if my screen is a bit too zoomed. Now it's a bit better. We wanted to start by a bit of an introduction to Python. And so, as I have said, Python is a very powerful programming language and very flexible. And it basically allows us to communicate with the computer so that the computer does whatever we want it to do. It's the language that we as humans and the computer, we both can understand. Interestingly, I'm gonna just say this very quickly because everybody says the same thing, but the name of Python doesn't come from the snake, but it comes from the British group Monty Python. And it's funny to say this because this reflects the idea of the developers of the language to make it something fun to use and intuitive to use. So it is supposed to be easy and understandable rather than difficult and complex. So Python's philosophy emphasizes the readability and to have a very expressive and simple syntax. And there are very basic things that you can do with Python. We will try to show you some of the most useful ones for you, but we highly encourage you to explore further and see how you can apply it to do the most basic things, to start from the most basic things to see how you can develop those further. So let's start by something easy. As you can see here, we are just asking the computer to do a simple addition for us. And so if I run this, the computer is just summing up 2 and 3. So we are getting the result 5. Now, the first thing to understand in Python is what variables are. So variables are a kind of shortcodes to a piece of data. Variables are used in Python to store values, so that every time that we want to call that value again during the processing, during the code, the computer will just go back and try to read the value that we assign to that variable. So now we are saying that this variable result is gonna be the result of the actual addition of 2 plus 3. So if we run this code again and we print result, sorry, we are getting 5. Now we are just printing the variable result that was here. We are not printing, or we are not asking for the, well, we are asking from the result of this, but what we are actually printing is the value that we have assigned to the variable result. Well, this is also to let you know that in Python you can comment on your code, so you can keep track of every exercise or every experiment that you try along the code. You can always make comments, marking them with the hash key here, and they won't be executed in the code. They are just to let you know what's happening there, why have you tried something instead of other thing. If you just want to try an operation and then run it a bit later, maybe you can comment on it and see how it goes. So comments won't be executed and they won't be printed. So now, what do you think that will happen here when we execute this code? As we said, we have assigned the value 5 to the variable result from here earlier. So if we execute this code, we should get the addition of the value that we assigned to result plus the number 5. So if I run this, yes, we are getting 10. So it's the result of adding up 5 and 5. Now, if we're going to talk about variables, about values that we can put into a variable, it's important to understand the type of values that Python recognizes. And so there are 4 types of values. There are integers that could be considered as whole numbers, and they can also be negative. There are strings, which are lines of text, like strings of text, and they should be included like this. And then we have floats, which are decimals, and booleans, which can only be true or false. Integers normally take more memory than floats, and they behave differently in the code. So it is important to be mindful of these 2 numerical values, because they can make changes in your code if you don't take them into account. Okay, so with this function, the function type, and the result in between curly brackets, sorry, the value in between curly brackets, you can ask your computer to tell you the type of value that you are in. If, for example, here we run this code, we are getting string, because this is a string of text that we put in between commas, single commas, right? If we do the same thing here, we should be getting a float. And here we should be getting a boolean, as you can see. And if we run this, we are getting an error. Now, as you can see, we are getting an error here because it says that the name result is not defined here. The name result, sorry, is not defined. Now, what we are doing here is we are assigning the value hello to the word result, to the variable result. But we are asking the computer to give us the type of the word results in plural. So the computer cannot associate these 2 words. So it's telling us that there is some sort of error, a name error in the code. So also, this is more information for you to know. There are some differences in between single commas or double commas, double quotes. But the important thing is that you shouldn't forget the quotes, because if you forget the quotes, because the code is gonna interpret your string, your text, as a variable rather than as a string of text. So, for example, here we are assigning the word goodbye to the variable hello. So if we print hello here, we should get goodbye, yes. But if we decide to print this hello, which is a string, with the function print, so we are putting the value hello to be given to the function print, we will get hello, right? Because here we are just asking the computer to print what is in between the curly brackets, hello. Here we are asking it to print the variable hello, which we have previously assigned to the value goodbye. Okay, so a string, integer, float, why is it so important? Well, when you try to sum strings of tests here, as we can see, these are not understood by the computer as numbers. They are understood as strings of tests. If we tell the computer that these are integers rather than just strings of tests, then we can make the addition, because we are changing the type of value of these two. But if we are working with a string, then the plus sign can actually be used to concatenate them. So, for example, if we say the variable is going to be interesting. Now print the string not very plus the variable a. We should be getting not very interesting. So here we cannot add up these two numbers well, if we try to run this just to see what happens. What happened here is that the computer understood these two as text, so the computer put them together. But if we wanted to sum up them into an addition, into a mathematical operation, then we should tell the computer that these both are integers, doing this, changing the value of them. Changing the type of the value. And then, however, the plus sign can also be used to put together strings of tests, like we are doing here. So it's different sorts of operations that we need to take into account when dealing with different values. Okay, now, in the same way that there are different types of values in Python, there are also different ways of storing the data. Lists and dictionaries are the most common and used types of storing collections of data. So, for example, here in the first one, we have a list. We are saying that the variable Beatles equals the list John, Paul, George, and Ringo. So if we ask the computer for the type of Beatles, we get list, as we have seen. And now this is the second most used Python way of storing data, which is a dictionary. Here we are saying, instead of creating a list, we are creating a dictionary in which we are specifying the name and the complete name and surname. Name only, and then name and surname. These dictionaries, as we can see here, are collections of key and value pairs. So there is the key and the value, the key and the value. So here again, if we ask the computer for the type of this variable, we should be getting dictionary. Other types of data ways of other types of ways of storing data in Python are also tuples and sets, but we won't be looking at those. Okay, I need to hurry up a little because I'm taking a lot here. If we wanted to access any of the items that are in a list, we could access them with the index, because lists are ordered. So the computer stores the list order. So we can access any of the items in them in the correct order that we gave them into the computer. So if we wanted to print, for example, the first value of Beatles, we would just have to run this code, and we will get John as we specify in the list. Remember that Python starts counting by 0, so the first value is always going to be 0. And if we wanted the last value of the same list, we will run this and we will get Ringo. The last value is always the last -1. So, okay. As we have said, dictionaries are collections of key but values. In order to access the keys into a dictionary, you use in order to access the values into a dictionary, you use the key as the index to access them. However, dictionaries are not ordered in Python, so we won't be able to find specific indexes just by asking for the order, like in the list. If we wanted to if we run this, we'll be getting John Lennon, and if we run this, we are getting an error. You can add items to the end of the list using the function append, and you can ask for the index of any of the items in the list by using index. I'm gonna go through. You can go through all these different functions here, try to understand them. But we will better go into more interesting operators, like, for example, the if statements. So most of the times when you want to get a program to do something, normally you want the program to check if the value corresponds to what you want it to be, and then do an operation regarding that value. So, for example, here, we are saying that the bassist of the Beatles is Paul McCartney. Now, if the bassist equals Paul McCartney, then these 2 points mean then print Paul played bass with the Beatles. So if we run this, Paul played bass with the Beatles, because as we said here, Paul McCartney has been assigned to bassist. Also, be very careful with the indentation. So this space here is very important in Python because it implies that anything that has the same indentation obeys to the same kind of operation, to the same loop. So if we miss the indentation, it won't be related to the previous specification. So we need to be very, very careful with the indentation in Python. Okay, so we learned the if statement here, but we can also specify if other conditions are not met. So here, for example, we are saying that if the bassist Paul McCartney, if the bassist is Paul McCartney, then print Paul played bass in the Beatles, but else, if something else happened, print this guy did not play for the Beatles. So the flow means that the condition in this line is checked in if bassist is equals Paul McCartney, and then if the condition is met, it prints this following line. But if the condition is not met, then it would print something else, which is the second line that we have here. Now, because the condition is not met, as you can see in the first line here, we should be getting the second line. This guy did not play for the Beatles. Okay. And we can also specify many other conditions by using the elif. So in this case, it will be the same. The bassist is Bill. If bassist is Paul McCartney, then print Paul played bass in the Beatles. Elif, so if other condition is met, Bill Wyman, then print Bill Wyman played for the Rolling Stones. Or else, something else, older conditions, print I don't know what that band this guy played for. So if we run this, we should get the last line. I don't know what that band this guy played. What band? Sorry, this guy played for, because Bill doesn't meet the first condition nor the second condition. And finally, one thing I wanted to show you a little bit are for loops. For loops are very, very, very useful in Python because they allow us to iterate over lists and also dictionaries if we want to. So a for loop can be paraphrased as, for each element named X in an iterable, like a list, do some code. For example, print the value of X. So if we want to say for any value for any variable in Beatles, print variable plus was one of the Beatles. So it should print that for each of the members of the Beatles. For each of the values in Beatles, print the member plus was one of the Beatles. So John, Paul, George, and Ringo. We should be already familiar with this, with the variable, the list that we are iterating to, the indent, as I have explained, we needed to specify that this line depends on the previous condition, and the function that we want to execute. Okay. Yes, I think that is mostly what I wanted to show you. There are obviously there are more things you should look at, but I don't want to spend all the session explaining on the basic of Python. So take a look at it, and obviously let us know if you want or you need any help with any of the others parts of this notebook, and we will be happy to show you a bit more. But I think that should be okay by getting the fundamentals of Python. And then I wanted to also show you a little bit of Pandas. So I'm going to open the second notebook, which is called Introduction to Pandas. So I have already opened it from the binder, and I have it ready here in my computer, in my screen. Okay, so one thing I wanted to say before that I forget is that the first time you open the notebook, it's better if you restart the kernel, so restart and clear the outputs. Like that, you will be able to do the operations, so you results, and you will be able to run everything in the code. Okay, so introduction to Pandas. Pandas is a library of Python. Libraries are kind of collections of code that have been developed by Python developers to enhance some sort of functionality, like dealing with data, dealing with text, many other functions. Pandas is an open source library, and it helps normally with data structures and analysis tools. So every time that you want to install a new library in your computer, you can do that from the console. So I can open from the terminal that you should have in your computer. It's called PowerShell in Microsoft, and it's called Terminal in Macintosh. And so you should be able to just run your Python and then install the library. And then every time you write a script or you're going to do something with that library, you would need to import it again. You can import it with its name, like for example, import pandas, or import it with an alias to make it easier for you to call it again later in your code. So normally Pandas is always imported with the alias PD because it makes it easier to work with it. Okay, so as we have explained before, Python has two numerical data types, with our integers like 10 and floats like 10, decimal numbers like 10.12. Now, if we say, oh, I haven't restarted my kernel as I told you to do. Well, this is a good practice to show you how to do it. I don't know if it's... Okay, now. So we are assigning here to the variable e the integer 10, right? So we are saying, give me the type of the variable e. We should be getting name e is not defined.
You didn't run it.
Ah, sorry, I didn't run the first one. Thank you, Gabi. So I'm gonna restart the kernel again. Okay, so I'm gonna run this first one. Okay, and now this one. Okay, so as I was saying, we have assigned the value 10 to e, and the type of e is an integer. Now, if we assign 10.12 to f, and then we ask if the variable e is an instance of the integer, then it says it's true. If we ask the same for f, it says it is false. If we want to specify what's the type of f, we just do the same thing, asking what is the type of f, and it tells us it is a float. Now, Python has two signs for division, the double slash and the single slash, and they do different things. Now, the double slash, well, if we run this, it will tell us it is false because they are not the same. The double slash normally, as we can see here, gives you the integer value of the, in this case, of the division. And the single slash gives you the float value, as we can see here. So as I was saying before, this is important for us because we should take this into account into our code, because it can, weird things can happen if we don't take floats and decimal into account. So if we print the type of this, we get an integer, as I said, and here we get a float. Okay, we could jump over this because we are explaining here that strings are lines of text, and they should be in single or double quotes, and we can concatenate strings with the plus sign. What else? We can transform strings, making them lowercase or uppercase. So, for example, if we run this, sorry, I haven't run the my string. I'm trying to be quick, but here. So here, if I run it again, yeah, we are turning this my string that I ran before into lowercase. We can also turn into uppercase, and we can also replace parts of the string. With Pandas, we can also deal with dates and time. If we import from date and time, we import date and date time. We can ask Pandas to help us dealing with dates. So, for example, if we run here just in case, date. If we say order matters, try this. So if we are saying that the variable d is equals date, day, month, and year, it's not working because there should be other order, and day is out of range for month. Okay, so if you are more interested into dates and times, then you should look at that. But I want to really show you how Panda works with data structures. So with list, dictionaries, and I'm going to try to show you series and data frames, which are the most common used data structures in Pandas. So in Pandas, series are the building blocks of data frames. Every series can be considered like a column in a table. So a series collects observation about a given variable. So if we import all these, we are going to try and create a series containing 100 random numbers, which go from 0 and 1. So we are saying for the variable s, please, Pandas, create the series in a random way, adding for each value in the range of 0 and 100. So if we run this, each observation in the series has an index and a set of values. So they can be accessed via the homonymous properties. So if we say for this series that we have just created, give me the index, it's telling us that it starts in 0 and then stops in 100 and step 1. If we create the list, we can see how it's going over to 99. We can also treat the values of the list. And operate the values of the list, here showing them as an array. For example, with the head, we can see the first 4, and with the tail, we should be also able to see the last 4. Well, the last 5, yeah. The value counts returns a count of distance values within a series. So for example, is there any number in the series that occurs twice? Zero, it says. And another way to verify the same thing, if there is any number in the series that occurs twice, we can also ask it to tell us if the series is unique. So if we run this, it is true. We can ask it what's the minimum value, what is the maximum value, and the median and mean. We can create series of dates and times I am not used to work with dates and time, so maybe Matteo wants to show you a bit more of that. What I normally work in my daily use of Python is more with data frames. So data frames in Pandas are a kind of in-memory collection of data that Python stores during the code to then go back to it and create any of the changes that you want to run through your code. So a data frame is a collection of series having the same length and whose indexes are in synchro. A collection means that each column of a data frame is a series. So each of the columns in a data frame are considered a series by the Pandas, and the whole data frame is the sort of in-memory spreadsheet that the code is creating for you to act upon during your code. So if we create a data frame, we can say, for example, the data frame, so dates equals date, year, rounded, and rounded. So if we run this, did I execute? Oh, I didn't execute this. Sorry, I'm trying to jump to be quick. And so we are getting here the series. We are it's telling us that it's a series of dates. You can go through all this after the lesson to keep exploring through Pandas. And then here, where should we get here? Yes. Okay. Now here, for example, we have event types, and we have a list. It's a list of fire, flood, car crash, and plane crash. If we use this random choice function, we get, let's see what we get. Ooh, sorry. And then we assert. I don't know if I haven't.
Just run the cell with counts. I think you missed one above the, yeah, just that one. And at this point, you should have all of them.
I'm not very used to dates and time, so if you want to say anything, Matteo, I'm more.
But this is just creating 3 lists of the same size, one with random dates, one with random counts for events, and one with actually labels of events. And then it was just a toy example to put them then together to simulate a small data set of plane crashes and fires in an hypothetic past. And then once you load them all together into a data frame, then you get 3 series that are coordinated and they form together a data frame.
Okay. So yeah, so it's like almost an hour since I have it. It's like 45 minutes. If you want to take over, Matteo, and go into Pandas deeper and Beautiful Soup.
Yep, I can do that.
Because I think all these bits, JSON and these bits, I think maybe they could be explored further. I don't know what you think. I don't know if we have time.
I think
for time, take as long as you need.
Yeah, so I will say if you want to show just finishing, as you prefer, you can either finish running the couple of cells that you were running and show how the data frame looks like. And so the one with events, counts, and dates, so that at least we show one data frame. And then I will go back to Pandas in the second part of my part.
Yeah, do that. Show at least so we get completion of that, and then yeah, we take all the time we need. None of these sessions so far have been under an hour. So.
Okay. Did I? Yes. And now here we are showing how the data frame looks. Yeah, with the date, the count, and the type of event that we assign. Here we are creating another data frame to the variable toidf data frame, in which we are creating a dictionary with the keys and the value, the dates, the count, and the events. So if we print this name date series is not. Have I not run something? Maybe I have not run something, but the result is the same. So you can pass directly a dictionary into a Pandas data frame and work with it, iterate over it, and work with the dictionary with the loop or the loop function that we have shown before. This I think is not going to work. Yeah, it worked. Yeah. And if we find the type, it's telling us it is a series. If we get more info out of it, it's telling us the rate index, the data columns, total 3 column, column which is date, then the index 0, 1, 2, then the columns, the count, the non-null, which are kind of empty values, and the type. And then if you want, Matteo, I can hand over data manipulation to you.
Yeah, if you agree, I will maybe start with the other notebook, and then
Okay,
when it comes to the second part, I will show a couple of things on the data frame.
Yes, that's fine.
Good.
Do you want to share your screen?
Yeah, if you can change to it, Gabi, I think I should be already great. So as Paula said, it's always good to restart the kernel and clear the output. And since I'm at it, I also wanted to, and since we're moving to another topic, to other two libraries, I wanted to show a couple of controls that you have in this environment that is the Jupyter Notebook. So Paula was running the cells. You have basically two ways of running them. One is to use the keyboard, and the other one is to use the icons of the notebook. So if you click on the run icon, then it will run the cell that you have selected. Otherwise, you can always, and it's quite convenient if you don't want to leave the keyword, press Shift and Enter together in a combination, and this is equivalent of pressing the run button. Another couple of controls that you have, each notebook, especially if it's a long one, quite structured, has a table of content. And with this button, you can toggle it, depending on whether you want to show it or not. An advice is if the notebook becomes very long, it's good to cut it into sections, and then it's useful to jump from one to another using the table of content. And this is also leads me to say that cells can be on two different types. Can contain other code, and these are the type of cells that Paula was running during her notebooks. And the other type is text. And if they are text, they contain Markdown, which is a way of doing some formatting, including links in a text. So if you run a cell that contains code, then you get the result of the computation back. If you run or execute a cell that contains text with Markdown, you basically see the rendering of this text. And I think, yeah, another two things, when you run things on Binder, as we're doing right now, it's an environment on the cloud, meaning it doesn't save you the notebook. So each session lasts for 15 minutes. If you are not active for at least 15 minutes, it will expire, meaning if you did some changes on the notebook, you will lose them. Since this is not very convenient sometimes, now they added in the latest versions a couple of functionalities. One is to download the version of the notebook that you have modified, which is convenient because once in a while you can download it, and then it's on your local machine, and you can later come back to it and continue working. Or with these icons here, you can also save the status of the notebook into your browser and then restore it later. So it's kind of providing a couple of functionalities to overcome the fact that once the Binder session is over, you will lose the content of your changes to the notebook. There is also, if you want to share with other people the link to the Binder, there is a handy button, and the same for GitHub. So this shows you where the notebooks are stored in GitHub, which is what Binder takes as an input to provide this interactive environment. Okay, so we are showing now in this part two libraries, Pandas and Beautiful Soup, which also leads me to say that I very much agree with the reason that Gabi and Paula provided for using Python, which is its flexibility. You can write small programs as well as big software, big and complex software. And the other reason is the ecosystem. And by ecosystem, we mean the libraries that already exist out there that you can combine and already start using without having to code them yourself. And this ecosystem is actually a big plus for Python, because no matter if you're doing data visualization, text analysis, NLP, machine learning with deep neural models, Python has some libraries that you can start using to do what you want to achieve. So that's actually a big plus of this language compared to others. So before we can actually use these libraries, we need to import them. And when we import libraries, it's actually one of the few commands that don't produce a visible output. So when you run this, the libraries will now be loaded and ready to use, but the cell hasn't produced any output. So PD, as was already said, is a shortcut for Pandas, and BS4 is the actual name that you need to call when you want to import the Beautiful Soup library, and stands for Beautiful Soup version 4, because there were several. So we have imported our libraries. Jupyter Notebook also have some functionalities to display some help. And if you actually use the help method on, for example, Beautiful Soup, which is an object inside the library, then you will get a human readable explanation of what this class is doing. And a class, it's used to create objects. So class is like the abstract definition of an object. Take, for example, a class for cars, and you can use it to create instances of cars. So if you want to have a specific car, then you instantiate, as we say, a class, and then you have an object. And this object has methods. And I'm going to show you now in the cells that come a few methods of objects that we will use. So the first library we encounter is Beautiful Soup, which comes in very handy if you want to process XML documents excuse me, without necessarily learning XSLT, either because you don't have time or because it's not necessary for what you actually want to do. So Beautiful Soup is useful when you want to get a bit of information out of the XML files and you are ready to look into the structure of these files to understand how to get this information. And Beautiful Soup provides you a parser for XML, that you can use to navigate and extract bits of information from XML files. So in the GitHub repository, we added a small collection of Epilogue files. Epilogue is a flavor or a subset of TI, the markup scheme that was divided specifically to encode descriptions. And this is the type of documents we will manipulate to show you what Beautiful Soup can do. So now we are also putting in practice a bit of the concepts that Paula showed earlier. For example, we initialize a variable that contains the path to the files. So that these files live in the data directory. If you go to the repository, to the GitHub repository, you will see that there is a data directory there containing the XML files. I store this information in a variable, and then I can do things on it. We work a lot with lists and dictionaries, and this, what you see in the lines between 7 and 11, it's a way of chaining multiple steps, multiple execution steps of the Python program to create a list. So I'm gonna run it first, and then I will explain what it does. So I run it, and the output is stored in the list, which is called XML files, which contains a list of paths to the XML files I have there. So let's go bit by bit into this command to see how this list was created. So in line 8, the first thing we do is to, well, let's start maybe from line 9. So first of all, we list the content of the directory. And this is done using the method, the function in the library OS that stands for operative system, and gives a series of high-level functions to deal with all the things that are related to your operative system. And this is basically listing of a directory. So if I take and isolate that function, and I call it on my data folder, then it's just gonna show you all the files that are in there. But as you see here, it contains also the README, which is not an XML, but it's a markdown file. So what I want to do is to iterate through this list and discard the files that are not XML because they don't contain the string .xml in the file name. And this is precisely what line number 10 does. And it's the if statement that Paula has introduced before. So it iterates in the list. If XML is not in the file, it moves to the next item of the list. If it's in the file, it will include in my XML files list the concatenation of the folder path and the file path. And at this point, we are actually good to go, and we can start using these files and read them using Beautiful Soup. So this is the construct that can be used to open a file and read the content from it. It's a different construct from what we have seen before. Before you have seen for loops and if statements, and this is a with clause. I will not go into the details, but it's basically creating a variable, this imp file, which at the end of the with statement, it's thrown away. So it's like to create some disposable variables that you do something with it and then you don't use anymore. And we are doing this because we want to read the file, create a Beautiful Soup object, like an XML object out of it, and then we will continue working with this XML object representation. So if I execute, when I execute this cell, it will have created the XML doc variable. So the variable, by now you know what they are. Let's look at the type. The type is Beautiful Soup. So there is a class in the library called Beautiful Soup that gives you, that creates objects that represent XML files. And each object has some methods. think of the method as like abilities. Like a person has abilities, things that the person is able to do. An object as a method. These are the actions that the object is able to perform. To inspect what they are, in Jupyter is quite easy. You can use the auto-completion, meaning you type the dot, which is the syntax used to call a method of an object, and then you press the tab. The tab will trigger the autocomplete that will show you all the methods and the variables that are accessible in this object. And for example, one of the methods, it's called children. There are some others. There is encode, extend, extract, fetch parents, find, for example. These are all methods of the object. If you want to see the documentation of what these methods are doing, a trick in Jupyter is to append a question mark at the end of the name of the method and run the cell. And this will show you in a kind of human readable way a brief explanation of what the method is doing, the parameters that the methods take as an input, and also will give you some information about the object that the method will give in return. There was a couple of things I wanted to say on the methods of objects. So here we have taken the first file in our list and we have created an XML object out of it. Let's see now how this this beautiful soup object, this wrapper, can be used to find things inside the XML file. And the first thing we do is to here I can remove it, find all the XML elements having with XML ID value representation. If we run it, it will find one. It will find one element. We can show maybe the content of the actual file, and if we look for representation, we can see where it was. So it's here at some point there is a category element that has ID representation, and this is the syntax of how you find it with Beautiful Soup. So it's a method called find all of the XML of the Beautiful Soup object, and as the parameter you pass a dictionary which goes into the attributes parameter, and the dictionary contains the name of the attribute and the value that should match. So what you're saying here is find all the elements that are matching XML ID attribute with value representation. And by definition, each ID in an XML document should be unique. So the length of my list, so the find all method gives you back a list. And the list, in this case, since you're looking for one element with one ID, should have the length of 1, meaning you expect to find only one element in your XML document with this ID. And assert, it's a new keyword in the Python language. That's why it's displayed in green. You can use it to verify a certain condition. So here I want to assert that the list of that I got back from the find all methods actually contains only one element. And it's true. I asserted and it didn't raise any error. If the statement that you are asserting is actually false, like for example, my list has length 0, then you will get an error displayed in red as you see here. This is a very important method of Beautiful Soup. I will maybe skip the finding elements by other attributes because it's very similar to the one we are just seeing. You can also find elements by name. So you can use find all to find all the person names and similarly all the bibliographic entries. One thing to note here is that, which can lead to some errors, is the fact that Beautiful Soup takes the lowercase form of the name element you're looking for. If we go back to the XML, we should actually be able to see that person name is written. Oh no, I thought it had a capital. Okay, never mind. I thought it had a capital N. But this is actually, I think in the case of XML elements with mixed case, it will lowercase the name, because I had some problems. I had some problems in the past. Anyway, this is to find any element with a given name, and it always gives back a list. There is also another way of navigating through a document, which is useful in those cases where you want to leverage the structure, the hierarchical structure of the XML. And in this case, you use the children, the parents, the siblings, all the concept that you should be familiar with, because they relate to the representation of XML as a tree. So you can find, for example, here we can start by finding one element. We want a div with type edition, and if there is more than one, I only want one. So there shouldn't be more than one, but since we get a list, we cut it at the first element. And here we are working with our div that represents the edition of the inscription. What we can do, for example, is to iterate, so to go through all the children of this element, of this edition element, of this div, and see what they are. So I do a for loop. I iterate for each child in the children of the edition element. And what I do, it's a bit verbose, but I'm printing some information for each child. So I print the type, I print the name, and I also print the content. So there will be elements that have a content, elements that don't, elements that have a name, and elements that don't. For example, here you have a new line that is actually represented as an element. The type, it's a string, it's this navigable string, but it's not an XML element. It's part of the XML, but it's not an XML element in itself. So the name is actually none, it means it doesn't have it. Whereas the name element, which is a tag, as opposed to be a string, it has a name, and it also has a content. In this case, it contains other elements. So you see here how I have like an abstract way of navigating through the hierarchy of my XML file. Okay, so let's move now to the last part of this session. I also wanted, before I finish, to emphasize the fact that what we have done in this session is a bit hardcore, of introducing Python and also two libraries at the same time. So bear with us if it takes a bit longer. The reason why we did it was to actually show how in practice they can be useful. So here I will show you how you put together beautiful soup with pandas. So let's say that we have a very concrete problem in our research. We have a bunch of Epilogue XML files, and we want to get some statistics about the names they contain. So we know where to find the names in the XML because we know the schema. How do we do this? So we use Beautiful Soup to extract all the person names from the files, and then we use the data frame. So think of it like a spreadsheet to organize our names. So there are two versions of what I'm going to show next. The first version, we will have time for it. The second one, we leave it for you to go back and see what are the differences with the first one. So the easy version, it does the following things. Takes all the XML files in the data folder, extract all the names, and then for each name, we want to keep the following information. We want to keep the surface 4 of the name. We want to keep its identifier, which is contained in a specific attribute. And we want to keep the type, which in some cases will be none. To do this, we could have written a series of cells and execute them. But actually, the notebook becomes very messy. One building block that you have in Python are the functions. So functions are bits of code to which you give a name, and they always have two things. They have an input and an output. So here, for example, there is a function called fetch input file names. It takes as an input my data folder, and it gives me as an output a list of files in the folder. Read XML takes the path to an XML file and gives me back a beautiful soup object representing the file. Find name element takes the beautiful soup object and gives me back the list with all the names, all the XML elements with name. And finally, the last function we use is parse the name element, which will retain only the information I'm interested in. So now that we have defined, a bit like Legos, our for function, now we can combine them together. And since we know what is the input and the output, we can operate with them. So this allows us to write a very, so first of all, I need to execute this because the functions need to be loaded in memory. And then I can combine them together. So here, for example, I have another example of this creating the list using some commands, which now I can also tell you the name. It's called in Python list comprehension. And if you continue using Python, you will use it and see it a lot because it allows to write very concise code that does also quite some complex stuff. So here, as we did before, first we run it and then we experiment it. So it's very similar to the previous one, so I'm not going to spend much time, but basically we fetch all the input files, we fetch all the name elements in them, and then we parse the name elements. So if I execute it, I get 33 names. I don't want to look at all of them, but let's see the first one. The first one has the surface form that contains a new line. That's why it's a bit funny how it's displayed. Maybe we can take the first 5. Yeah, so the others are more normal. So in all cases, there is no type. And then you have, for example, a Cassandron that has ID Cassandros. And this is a bit to disambiguate the names that occur within a document. Different forms of the same name will get the same ID. So what I created is a list containing dictionaries. Each dictionary, we have seen the dictionaries with the Beatles example before, has 3 fields: surface, ID, and type. And we do this for all the names. So here is not nice to read, but I can give you all the names. So it's using 2 data structures we have seen so far. And once we have this list of dictionaries, then we can create a data frame out of it. So maybe I will just execute this. So it creates a data frame, and this is how the data frame is represented. So it's really like a spreadsheet. It has 3 columns, a column with a surface, with one with the ID, and the other one with the type. And it also has the index. The index is like a series of ID for each row in my spreadsheet. Since in this case, we have an ID already coming from the XML, what we can do is to tell Pandas to actually take that column as the index. And this is done by using the setIndex method. So we say, for this data frame, use the column ID as an index. And then we pass drop equals false, because if we remove the drop equals false, Pandas is actually going to remove the ID column. It's going to transform the ID column into the index itself. In order not to lose it, because it might be useful for the kind of statistics we want to do, we keep it, and that's why we use this parameter. We encountered head and tail again. They display the first n number of rows. You can have 10, by default it is 5. You can even have more. You can have 2. So you can look at the beginning and at the end of your data frame. I leave the advanced version for you to practice, and I will conclude very briefly showing how Pandas can answer some questions about these names. So we want to say, to know, for example, for each type in the XML attribute type, how many names of that type there are. So in this case, we're not going to use the entire data frame, but we use a single column. And the single column, as you have seen before, it's a series. And the combination of series creates your data frame. So here we're operating on the single column, and on the column, meaning the series, we ask the count of how many records per type. And we get already 3 patronymic and 2 surnames. You might have noticed something special about the counts above is that Pandas is already quite clever, and it's not counting all the values that are none. So as we can see here, there is a bunch of, the majority actually of the records don't have a type. So in the counts, it's quite handy. It's already filtering out these so-called null values. We can also look at the disambiguated names to know how many times each disambiguated names occur. So we have Christos occurring 3 times, Octavius twice, but then the majority of the others, they are occurring only 1. Just to show you what you can do in a Jupyter Notebook and with Pandas, you can also plot this information. So you can also this is not very telling because it's a very simple distribution, but you could see how your names are distributed in your small data set that you created. This more visually, and you can also do it using some statistical properties. So for example, I want to know how many times the most frequent names occur, and the same for the least frequent. It's respectively 3 and 1. And I also want to know whether the names in their surface forms they occur more than once. So this I will do it this way, so I can see that only actually Apollonos occurs in the same form more than once. And then, of course, if I look at the disambiguated forms, it's different because they have already been matched by the ID. And then on this, you can also do, you can see the mean, you can see the median. There is a command for to describe the properties, looking at more the percentages of the population. So what you see here, it's the minimum and the maximum value. This we have seen it. We also get to know that 70% of our names actually occurs only once in the dataset. We have done this for a very small bunch of files, but imagine doing this for 1,000,000 files or 1,000 files. It's quite a handy way of getting to know your data in a more numerical and statistical way. And I'm gonna stop here. Just in case there is anything we want to say before explaining the exercise. Gabby?
If anyone had anything they want to add or comment or ask at this point, maybe before we get to that. I had a question. I was slightly shocked when you said that Beautiful Soup lower cases all the XML, because that's an error.
The XML, the name elements.
The element names, yeah, that's an error. Because
Okay,
XML name elements are case sensitive, specifically by definition. They have to be. And so if you have a first name with a capital N and first name with a small n, they're 2 different elements.
This needs to be verified. So this is what I seem to remember from having worked with it and struggled with it in this case, but I wouldn't, be 100% sure about this. So,
but, I mean, it did look from your fields that was. I mean, I saw the view you had of the XML file when you printed out the whole XML file. That had already lowercase all the elements. That's why you couldn't find first name with a capital N.
And in the XML, they are okay. No, so
Incorrect. Yeah, the first name with a capital N.
Yeah.
Well spotted. I mean, this is it's a simplification that the library does, I guess, for convenience, and also because the API of the library maybe wants to make easier for users to actually find the name, no matter whether they are looking with the right capitalization or not.
As you pointed out, it actually makes it harder, because if I search for first name with a capital N, I don't find it, even though it's meant to have a capital N. So if you come with an XML knowledge, then it is confusing. I totally agree. But there are, I would say, quite a few people out there that are parsing XML without knowing very well what they are dealing with. So for those cases, it might be actually useful that the library already does more than it's correct and more that you ask for you. I think that's a bit perhaps the reason why. But it's it's interesting. So thanks also for confirming my memory. So there was actually the capital in the original XML file. Anyone else wanted to raise anything?
I just wanted to say that it is a bit too much information for a first class, so maybe ask the students to go through the notebooks, like take the time, run each of the exercises, go through them carefully, and don't get too scared of how much we have trying to explain.
Absolutely. I think if everyone follows along live, they might want to pause the video while they follow along, try a couple of things out, check they understand, and then go back. I think that's as you'd expect. I mean, we couldn't do it in real time because this would take 3 hours to do just what we
exactly. So Python can be a bit overwhelming at the beginning. So
I think this was clear, and I think I think that'll be fine for people going through it in that way. If they use this video as a resource rather than as somebody in front of a room, I think it'll work like that.
And the nice thing, if I might add, about the notebook is that you can interact with each cell, and the best way of learning is actually to try to break it. So try to raise these scary red arrows in the interpreter, trying to change a value and see what happens. And you can do all of this in a sandbox, in an environment that is safe. You're not, breaking anything. You can rerun as many times as you want the code. So it's a kind of a safe sandbox to play and try to understand the code also by breaking it.
Yeah.
So basically, bottom line of you can import and tackle with different type of text or file formats into the this sort of Jupyter notebook. And can you of course you can probably, but a couple of words about if you do something, if you write your own code, how can you integrate it into export it and integrate it into other stuff that you're doing, if you get me.
You mean, for example, for a Jupyter notebook?
Yes, well, generally what you can do based on your experience with this after you learn some coding in Python. What are the possibilities?
Well, the possibilities, I think they go from the day-to-day script that you can use to parse your data, to change commas in a long manuscript, to do some data cleaning, find and replace by regular expressions. These are some day-to-day usages of Python code, but you can also write some complex libraries that they do some things to solve some research problems, trying to extract, I don't know, references, bibliographic references within publications, or interact with triple stores. So if you are publishing code that is organized as a library, then you want to publish it in repositories where other users can install it and import it in the same way that we did for the Beautiful Soup. But probably you don't want to bother doing the same if it's only a small script that you will use once or twice. And you can also use Python to create some command line script. so scripts that you execute from the command line that are like wrappers of Python scripts. So that's a bit to give you different uses. And then there is multiple possibilities for publishing this code online. You can go for GitHub if it's only sharing a small script. You can go for a GIS. So the GIS in GitHub, there are ways of publishing a single notebook or a few lines or snippet of code that programmers use quite often. And then if you have developed a full-fledged library, you can put it in PyPy, the repository that Python uses to share code, and from which you can do pip install and the name of the library. But that's kind of a more advanced use case. It means you already package your code in a way that other people can install it in their machines. So there is a full spectrum of uses, I think, that go from the day-to-day kind of business, your own computer, to having a library like Pandas that is used by millions of users, and it can become part of the data science ecosystem in Python.
Thank you.
Shall we conclude with the exercise?
Please.
So the exercise, do you see my screen?
Yep.
We ask you to, of course, if it's one of the first times you're writing Python code, it's hard to write all this code by yourself, but it's a bit easier to modify the code that we have provided for you. So what we ask you to do in the exercise is to find another piece of information in the XML Epilogue files that you want to focus on. So don't take the names because it's already done. Take, for example, the lemmata from the edition, or the variants, or the bibliographic elements, or some metadata information. And then try to change the code we provided to do the same. So to collect all these elements of interest, let's say all the bibliographic citation, put them into a data frame and do some basic commands like the ones I showed: value counts, min, max, describe, to see what your collected elements look like. So what you can do is really go to the to my definitions of the functions, which are here. Using Jupyter, you can even copy the cells and paste them at the end. So here I can paste them now at the very end. This is also quite handy, and we didn't come to talk about it. So now you have a copy of these functions, and you can modify them. You can change the names, you can change inside how they work, and then based on this, you can reuse the same snippet of code with the list comprehension and try to put them together, create a list, and populate a data frame. That should be doable, provided that you find how to re-put together all these elements and try to change a bit how they work inside.
Great. So yeah, the other thing I'd just quickly point out that on the session page for this session, on Sunoikisis DC, there is another description of this exercise given at the bottom there of the session page. There's also some information there and some links on how to set up your own Jupyter Notebook environment so that you can work on something that you can save the results of, and you can go away for more than 15 minutes and come back and it'll still be working, rather than working in the binder that Matteo and Paula provided for you. And you can either do that using the Anaconda package or on the cloud using either Azure if you're a Microsoft user or Colab if you're a Google user. And there's links there. And we've also made available, or they've also made available for you, several useful resources for learning more about Python, various things there that you might want to follow and look at. And they'll give you both some general things. The Programming Historian has several small tutorials on there. Some of these are guides to specific libraries, as we've seen. Python for Everybody is an entire Python course in 16 chapters, which is actually very, very easy to use. I'll tell you how easy it is. That's how I learned Python. And unlike Paula and Matteo, I am not a programmer. So you know, these are mostly things for if you want to do more than just the exercise. If you would like to use Python, you know, for a term paper or just generally in your life and research, then there's places you can find. And there's hundreds of other places for, you know, you can buy a book, you can go on a course, you can, you know, sorts of things. But these are good places to start. And there's also some readings on here and so forth as usual in this session. So yeah, just wanted to point that out just quickly.
Thank you, Gabi. No.
Thank you.
I would like to emphasize something that Matteo mentioned in passing, but I think it's important that you can, when manipulating strings of text or XML code, which is basically also text, you can apply what you should already know about regular expressions. I don't know if the rules are absolutely the same in Python as in other environments that we saw, but basically this could be a very powerful research tool when integrated into searching and manipulating with strings.
I agree.
Yes, absolutely. I think that's and as if you're following this whole semester of classes, regular expressions was taught in the first week. We did a lot on XML last week, so you can combine those things for this exercise. So that's I think useful. Yeah. Great. I don't see any comments on YouTube, so I think we're probably done for today. People may have questions in the future. If they're following a class, they can ask their tutor. If they're not, they can try and web stalk Matteo or Paula and find their email addresses and ask them questions. Otherwise, thank you both very much. I hope people will join us next week for the second of 2 Epidoc sessions where we're talking about publishing from Epidoc XML with Martina Filosa from Cologne and Simona Stoyanova from Nottingham. So please join us then. Thanks again. Cheers.
Thank you.
Bye.
Thank you. Bye-bye.